Hi everyone. So today here we are going to take a log differentiation here. So let me recall what I gave you before. I gave you power shortcut formula. What is shortcut formula? If you recall, if you have x to the power n, I need to take the derivative of this. X to the power n, it will be just n x n minus 1. And here, of course, you multiply by x prime. What is x prime? X prime here. And then x prime here is 1. So what did you get? You get n x n minus 1. Right? This one we call it polynomial because your unknown x or your variable x to the power n. So this one we call it polynomial of degree n. Polynomial of degree n. I give you also, if you have b to the power x, that is called exponential because your base here, b here, we call it base, and that is positive number. And raised to the power x, what is your x? Your unknown. So your exponent here is what? Is x. Your exponent here is x, and your base here is a number, and this one we call it exponential. I need to take the derivative of this. The derivative of any exponential should be exactly the same, multiply by ln b multiply by the derivative of the exponent, What is x prime here? X prime is 1. So you have b to the power x ln b. So this one we call it, it's polynomial, right? Because your variable x raised to the power n, and n here is a number, and here your exponential, this one we call it exponential because what you have here is base, which is positive. Base here is positive number. This notation here, it's positive number, right? So then positive number raised to the power here x, which is your unknown x. That is called exponential, and we know how to take the derivative polynomial. We know how to take the derivative of exponential. So now I need to, what happen if you have your, for example here, your f of x equals, say, x to the power x, or x to the power x square, or you have x to the power log x, right? Or you have something like this. So what do you have? You have x raised to the power x, and here x to the power x square, and x to the power log x. So how to take the derivative? This one is not polynomial because your exponent here is variable, and also your base here, your x, that is x, and here raised to the power x. So that is not polynomial. And that is also not exponential because your base here is not positive number. That is your x here raised to the power x square raised to the power function, which is x square or log x, or you could have here x to the power e to the power x, like this. So in this case, your exponent here is very clear, is not a number, and also your base here, which is x, is not here positive number. So that is not exponential and is not polynomial. So now how to take the derivative of this? That is our goal for today. How to learn how to take the derivative of these very complicated functions, x to the power raised to the power function x. How to take the derivative? Here is the following steps. Here we are going to apply. What do you have? Maybe I give room for myself here, so I just try to move a little bit here. All right, so I'm going to give here some problem here, and then how to solve this, how to take the derivative, and then so let me show you here. Go back here, up here, and just try to show you the. So I'm going to follow the steps here. That's what I suggest. Our goal to get the derivative of y with respect to x. So now let me give you example here before, and then we'll follow the steps here that I'm talking about. If you have, say, f of x, or you have your y, that is your y here, or your f of x is the same. Your y equal f of x, right? Equal to, say, x to the power x cubed. So now what is the question here? The question here is, I need to take the derivative. What is the derivative here? I need to find dy by dx. Find dy by dx, right? So the step number one, they take log ln, natural log, that is ln, both sides. So step number one, I'm going to follow. I'm going to take, so ln y equal to ln x cubed. So I'm taking ln both sides. So your equality here, it should be the same because I'm taking both sides the same, ln y ln x to the power x cubed. So now I'm going to use look what you have, simplify using law of log. I have to recall law of log. What is the one here? I have to simplify. The law of log I'm going to use for all these kind of problems. Here, one, it could be log A multiplied by B. It will be log A, right, plus log B. That is one. Number two, log A over B. It will be log A minus log B. Number three, that is the one I'm going to use also. If you have a to the power r, I can put r in front, so you have r log A. So here, look what you have. You have, that is your exponent here. I'm going to use this one. So ln y, I cannot do much, but here I can simplify this. How to simplify? I can put x cubed. I put it in front our log. That is r. What is my r? X cubed. So I can put it in front. So this one, I need how to simplify this. To simplify ln y, it will be the same. And here ln, I put x cubed in front. Multiply here, it will be ls. So I took the exponent and put it in front. So that is step number 2. What is step number 3? Step number 3, I have to take step number 3. That is step number 2. What did I do for step number 2? I took step number 1. I took log both sides. I have to use law of log, right? So now step number 3, step number 2. Here I have to go ahead and so here I took natural log both sides. Step number 2. I simplify using law of log, and step number 3, I have to take the derivative with respect to x. So now, in order to take derivative with respect to x, that is step number 3. Let us recall the derivative here, which is you have ln f. If you have ln f here, if I need to take the derivative of this, it will be 1 over f multiplied by f prime. 1 over f multiplied by f prime, right? That's the rule. We have taken that before. So now I have to take the derivative of both sides. So now ln y, I'm taking the derivative of this left hand side, and also the right hand side here, that is the one, right? I'm going to take the derivative of this. Now let me read this one. X cubed multiply by, did you hear the word multiply by? Ln x multiply by means product rule. So here, this one, you could do separate. So what is the derivative of this? The derivative of that, it will be 1. What is your f? Your f here is y. So it will be 1 over y multiplied by y prime. 1 over y multiplied by y prime. Remember, your y prime here is what? That is the goal. I need to get dy by the x. What is, find dy by the x, which is y prime. What is dy by the x, which is y prime. Now, what do you have here? X cubed multiplied by ln x. X cubed multiplied by ln x. So you have product rule. Recall what is product rule here. Product rule, if you have f multiplied by g prime, it will be prime, it will be f, right? G prime plus f prime g, right? F g prime plus f prime g. So that is your f and that is your g. So it will be x cubed, the derivative of ln x prime plus x cubed prime multiplied by ln x. That is called product rule, right? I'm using product rule, right? So now let us keep continuing here. 1 over the left hand side, 1 over y prime. The right hand side here, x cubed. What is the derivative of ln x? Ln x here is the rule I'm going to use. What is your f? Your f is x, so you have 1 over x. 1 over x, that is your f, x. So multiply by x prime. 1 over x multiplied by x prime. Here, x cubed. And here, what is the derivative of x cubed? It will be 3x squared multiplied by ln x, right? 3x squared ln x. What is x prime, guys? X prime here is 1, because x prime is nothing but is dx by dx, the derivative of x with respect to x, which is just 1. So if I simplify this here, you have x cubed divided by x, and here 3x squared ln x, and here you have 1 over y prime. So I can simplify this. You have x squared plus 3x squared ln x, right? And here 1 over y prime. What is the last step? So here, if I go for the step that I summarize here, I said here differentiate both sides. That's what I did. Then I have to solve for dy by dx. What do you mean solve for dy by dx? Solve for dy by dx. What is your y prime? So the number in front y prime should be 1. So here what I got here, so you have 1 over y. So I have to get y prime. I solve. When I say solve, for y prime means you have, if I have to multiply both sides by y, so you have y prime equal y, and here x squared plus 3x squared ln x. Now, what is the last step? Substitute by y. What is your y given here? Look what you have. Substitute y equal f of x, so that your final answer here is written just in terms of x. So what is your y, guys, here? Or your y here is x to the power x cubed. Your y is given here, your f of x or y, x to the power x cubed. So I'm done here. So what is your y? Just replace y, it will be x to the power x cubed multiplied by x squared 3x squared ln x. You don't need to simplify this one here because already you got y prime, and that is our goal. What is your y prime? X to the power x cubed, which is y, multiplied by the derivative here, what I have. So let me summarize what I did. What I did here is not polynomial, is not exponential. So how to take the derivative? I have to bring this exponent down. How to bring the exponent down? By taking log both sides, ln both sides. So that's what I did, and then I use one of the property of log here, which is if you have a to the power r, I put r in front, log a, and then I put x cubed in front. So that is what I did. So here, look what you have, x cubed in front, so you have x cubed ln x. Then I have to take the derivative of both sides. I use the rule of log, which is 1 over f prime. So that's what I do. But here what you have, x cubed multiply by ln x. When you hear multiply means you have to use product rule, and that is what I did. And then you solve for y prime. That's what I did. How to solve for y prime means y prime, the number in front y prime is 1. So I have to multiply both sides by y. I multiply by y. Then when I multiply by y, so I should write here what I did. I multiply by y both sides, multiply y by y both sides. So solve it for y, you are done. Okay, so that is kind of one example here. I give you this one. Let me give you another example to appreciate this what's called log differentiation here. Example number 2. So sometimes you have, say, y equal to 2x plus 1 to the power 3 multiplied by 3x minus 5 to the power 6, right? So now if I ask you find what is to get here, find dy by dx, I need to get the derivative of that with respect to x. So let's just read this one. You have a bracket to the power 3 multiplied by another bracket to the power 6. So now when you hear multiply bracket multiply by bracket, that's product rule. And then after you apply product rule, you must apply power rules because you have a bracket to the power n. So that is power rule. So you have a product rule and power rule, like two rules. So now what will happen if I use log differentiation to simplify this and see what it will be simpler or what. So here, so if I ask you find dy by x, and then you have the option to use just any derivative, right? But if I ask you to use log, using here log differentiation here, log differentiation, then you have to follow the step, which is take the derivative of both sides. I'm taking log ln of both sides. So what you have here, 2x plus 1 to the power 3, and here 3x minus 5 to the power 6. I'm taking log or ln both sides. And now I have to use, that is step number 1. I'm taking log both sides. Remember those 5 steps. Step number 1, take log both sides. Step number 2, I have to use law of log to simplify. So how to use simplify? Look what you have. If you have log a multiplied by b, then it will be log a plus log b. Right? So here what you have, you will have here you have a product here. So that is the first one is a, right? If I use different colors here, so maybe that is a and that is b. So that is, this one here is a and this one here is b. So a, b. So it will be ln y equal to ln 2x plus 1 to the power 3 plus that is plus here log b, which is ln b, which is 3x minus 5 to the power 6. right? So I use log A multiplied by B, it will be log A plus log B. So that is your A, right? And that is my B, right? So that is what that I have. So now I have to recall, you have a bracket. So if you have log A to the power R, A to the power R, I can put R in front. So you have R log A, R log A. So I can put R in front, it will be R log A. So here, what do you have? You have ln y, right? Maybe I go to the using the different colors here, right? So here, right? So here, just try to. All right. So here I have to use. So what is your R here, guys? Your R 3, and what is your R here? 6. So I can put 3 in front. So you have 3 ln 2x plus 1. And here I can put 6 in front. So what do you have? 6 ln 3x minus 5. Right? So can I simplify more? No, that is the maximum you can simplify. And then after I simplify by using law of log, what is the next step? Take the derivative of both sides. So I have to take the derivative of the left hand side here and the derivative of both sides. I'm just taking the derivative of both sides. So you have 3x minus 5, the whole thing prime, the whole thing prime. So what do you have in the middle here, guys? You have in the middle plus. If you have in the middle plus, means you take the derivative term by term. The derivative of the first term, that is the derivative of first term, that is first term here, and that is second term. So you have first term plus second term. Then you take the, go ahead and take the derivative of the first term plus the derivative of the second term, which is 3x minus 5 prime, right? And then what you have ln y. So what is the rule? The rule here is, recall here, the rule here is if you have log ln f prime, inside here f, it will be 1 over f multiplied by f prime. So what is it here inside? What is inside here is y. So you have 1 over y multiplied by y prime. What is y prime? Y prime, that is the question. The question here is find dy by dx. Look what you have the question here. Where is the question? The question here is find dy by dx. I need to get y prime dy by dx. So it's not 1. All right. So now 3, it's a constant. I can grab it outside. So what do you have? 3 outside of your derivative. So what is inside? ln 2x plus 1, the whole thing prime, and 6 outside. So you have 6 outside here. So what do you have? ln 3x minus 5, the whole thing here is prime. All right. So now go ahead and finish the problem. So you have 1 over y prime. You have 3. So now what is the rule here? What is your f? Your f here is 1 over 2x plus 1. So that is your f multiplied by f prime, which is 2x plus 1 prime. Here you have 6. What is your f? 1 over 3x minus 5 multiplied by 3x minus 5 prime. Right? So if I go ahead and take the derivative, so you have 1 over y prime. You have 3, and here 2x plus 1. What is the derivative of 2x? Just 2. What is the derivative of 1? 0. 0, right? So here you have 6, and here 1 over 3x minus 5. What is the derivative of 3x? You get 3. What is the derivative of negative 5? Is 0, because it's a constant. Derivative of any constant should be 0. The derivative of 3x is just 3. If I simplify this, 3 multiplied by 2, you get 6 over 2x plus 1. 6 multiplied by 3, you get 18 divided by 3x minus 5, and that is 1 over y prime. So step number 3 here, I took the derivative of both sides. Then I finished the derivative. What is this next step? Just solve for y prime. Solve for y prime means you have to get rid of y here. So I have to multiply both sides. Multiply both sides by what? Multiply both sides by y. Right? So you have y prime. It will be y, open big bracket like this. You just copy this one here, which is 6 over 2x plus 1. And here, 18 over 3x minus 5. Right? So now what is the last step? Replace y by your y by the function of f of x. What is your y here? Look what you have. That is your y here, the whole thing. So that is your y. Just replace y by whatever you have here, which is 2x plus 1 to the power 3, 3x minus. So just copy. So it will be here, just copy this one here. So maybe I look to my notes here. So you have 2x plus 1 to the power 3 multiplied by 3x minus 5 to the power 6. And then you have the bracket, which is 6 over 2x plus 1 plus 18 over 3x minus 5. So this one here is nothing, but that is your y. That's come from where? That is your y prime. That is the question I need to find. Y prime here. So how did I get y? That is what is given when I start the problem. When I start the problem, look what you have here. That is example number 2. That is your y given already like this. Just replace that so that everything on the right hand side, as you can see, in terms of what? In terms of x. In terms of x. Here, in terms of x, the derivative here is x. And here also your y in terms of x. All right. So that is our what's called here our differentiation. So here, if they ask you to use log differentiation, then log differentiation means you don't have option here. Then either. But if I ask you to find dy with x, some people can apply product rule and use power rule. At the end, it will be correct. Very much you get the same. Somehow you get the same for this one. Okay, guys. So it will be mathematics. The beauty of math, you could have many ways to take the derivative. So now let me solve another example here. That is I need to solve. So if you have y equal third root here, third root of what you have x cubed e to the power 4x divided by x plus 3 to the power 4. X to the power 3 to the power 4. So the whole thing under square root. So now I need to find what? I need to find dy by dx by log differentiation. By log differentiation. All right. So here, as you can see, normal derivative. It's this one is what? Third root. If I simplify this, what do you have? You have x cubed, right? E to the power 4x over x plus 3 to the power 4 to the power what? The whole thing to the power 1/3. The whole thing to the power 1/3 because you have 3 here, and you took the whole bracket, whatever under the radical here, which is your third root, to the power 1/3. So as you can see here, you have power rules, you have product rule, x cubed multiplied by e to the power 4x. So that is product rule. Also you have exponential divided by x plus 3 to the power 4, that is quotient rule. So it's too many rules here. If I do it in classic way or normal way, you have to apply product rule, you have to know the derivative of exponential e to the power 4x and so on. So now let us see or appreciate here how to use log differentiation. So what is the step? Step number 1, just take log both sides. So now I'm going to take log both sides, right? So let us do ln both sides. So I have x cubed e to the power 4x, right, over x plus 3 to the power 4, the whole thing to the power what? 1/3, right? So that is your r. If you have log e to the power r like this, it will be r log a. So 1/3 I can put it in front, right? So ln y. I have to use step number 1. I took ln or log both sides. Step number 2, I have to use law of log to simplify as much as we can, and then before I take the derivative. So here your r 1/3 I can put it in front. Open bracket, it will be ln x cubed e to the power 4x divided by x plus 3 to the power 4, right? The whole thing, right? And now I have to recall, if you have log a over b, it will be log a minus log b, right? Log a over b. So here ln or log have x cubed e to the power 4x divided by x plus 3 to the power 4. So that is your a. So if I use different colors here, right? So that is your a here, the red ones, a. And whatever you have up, that is your a, right? Whatever you have down, that is your b, right? A over b. So what do you have? You have ln y equal 1/3 outside, 1/3 outside, and then inside it will be log. Take whatever you have up, which is x cubed a 4x minus log x plus 3 to the power 4, right? So that is your a, and that is my b. Log a minus b, right? So that is the rule. And now, can I simplify more? Yes, you can simplify before we take the derivative. So look what you have. You have x cubed multiplied by e to the power 4x. So the rule, if you have a log a multiplied by b, it will be log a plus log b, right? Plus log b. So here x cubed, so you have 1/3 outside here. So this term here, this term, maybe I use different ones here, maybe green. So I'm going to use the green one here, this term. I'm going to break it down. So it will be log x cubed multiplied by 4. So you have log x cubed plus log e to the power 4x. E to the power 4x. I put it between brackets. So that is the green one. That is our first term. Minus here, maybe I use different colors. Maybe I use blue or something like this. The second term here, it will be your r, log a bracket to the power r. So I can put r in front, and then what do you have inside? X plus 3. Right? So now, can I simplify those two? Yes, you can. So still I can simplify x cubed. You have r again. So I can put 3 in front. So you have ln x. And here 4x, I can put it in front. So you have 4x ln e. So I put 4x in front, look here. And here minus 4 ln x plus 3. Close the bracket. Now, I have to, can I simplify more? Yeah, no, you can. Look what you have, ln e here. If I use technology, you have, it's 1. ln e, when I use technology, you get 1. And so you have 1/3, right? So 1/3. So if you want, I can multiply 1/3 by each term here. So what do you have? 1/3 multiplied by 3. 3 cancel with 1/3. So what do you have? You have ln x. And here, 1/3 multiplied by 4. 1/3 multiplied by 4, you get 4 over 3x. ln e here is 1. And here minus 4 multiplied by 1/3, you get minus 4 over 3 ln x plus 3. Right? So that is ln y. So now, is that the maximum you can simplify? Yes, that I cannot simplify more than that, because remember, log a plus or minus b. Remember here a remark. I'm just repeating myself. Remark, log a plus, just this remark here. If you have log a plus or minus b, that is not equal, does not equal log a plus or minus log b. They are not the same. So because of that, I cannot break that down. So that's the maximum you can do. So now, after I simplify using law of log, what is the next here? Just go ahead and take the derivative of both sides. So take the derivative of both sides. So that is ln y prime. And here, the whole thing, which is ln x, I'm just copy 4/3 x minus 4/3 ln x plus 3, the whole thing prime. I'm taking the derivative of both sides. Right, what you have in the middle here, guys, plus. What you have in the middle here, minus, which is good. If you have in the middle plus or minus, means I have to take the derivative term by term. The first term here, the second term here, and the third term here. So you have 3 term, ln x 1 term, 4 over 3x second term, negative 4 over 3 ln. So what is the derivative? It will be, I'm going to take the derivative term by term. So minus 4/3 ln x plus 3, the whole thing prime, So now ln y prime, right? So what is the derivative of this? Look, that is your f. It will be 1 over f y prime, 1 over f prime. Here, what do you have? You have 1 over x prime. That is your f, which is 1 over x prime. So now what is the derivative? 4 over 3. 4 over 3, that's a constant. I can factor out 4 over 3 outside. So what do you have left? X prime. And here, negative 4 over 3, that's a constant. I can grab it outside. So what do you have left? You have ln x plus 3 prime. The whole thing prime, right? So now, let me finish this. So 1 over y, you have 1 over y, y prime. And here 1 over x, x prime. What is x prime? X prime is 1. What is y prime? That is a question. I need to find y prime, which is dy by dx. So y prime here is, that is the one you need to find. That is the one, the goal to get y prime. So what is x prime? Is just 1. So you have 4 over 3. X prime here is 1. And now what is the last term? 4 over 3. What is the derivative of this? What is your f? your f here is x plus 3 multiplied by f prime. So 1 over f, that is your f prime. And then if I finish this, 1 over x, 4 over 3, that's a constant, negative 4 over 3. And here 1 over x plus 3. So what is the derivative of x here? Is 1. Very good. What is the derivative of 3? 3 here is a constant, which is 0, So what did you end up here? You have y, 1 over y prime. So now what is the last step? The next step, you have to solve for y prime. Solve for y prime, because you need to solve for y prime. So what I need to do, just multiply both sides by y, right? So if I multiply by y, you get y prime equal y, open big bracket, just copied all of this, which is 1 over x plus 4 over 3 minus 4 over 3 multiplied by 1 x plus 3, right? So that is, what is the last step? Replace y by substitution by the function of x, because your y prime, you must have the right hand side here, everything in terms of x. So what is your y? What is your y? The question here, what is my y? Here is your y. Look what you have, the whole, this one here. Just copy, that is your y here. I've just copied this down, then you are done. That is, you are done. Right, so here, what is your y? I'm just copy, it will be third root of x cubed e to the power 4x divided by x plus 3 to the power 4, the whole thing multiplied by 1 over x plus 4 over 3 minus 4 over 3 multiplied by 1 plus x plus 3, and then you are done. That is your y prime. That is your y prime. All right. So let me summarize what I did so that you can follow what I have done. I am follow the steps. Here it is very complicated y. I need to use to find or to figure out what is dy by dx. I have to use log differentiation. Then what I do, I took log both sides. And then I have to use law of log to simplify. So the whole third root here, third root means take whatever you have under square root here or under radicals to the power 1/3, right? So now when I take log both sides, 1/3, that is my r. If you have r here, I can put 1/3 in front, right? Then I put 1/3 in front. I have to use law of log. So here what you have a fraction. If you have a fraction, a over b, then it will be log a minus log b. Whatever you have up, that is your a. Whatever you have down, that is your b. So it will be log, I took whatever I have up minus log whatever I have down. And then I keep continue. What do you have, how to simplify? Here you have a bracket to the power r. I can put r in front. But this one, x cubed multiply by e to the power 4x. When you say multiply, means you have to recall log a multiplied by b. It will be log a plus log b. So a here, the first term, which is x cubed plus log e to the power 4x, right? So here you have x to the power 3. Again, that is my r. I can put 3 in front, that I did. 4x, I put it in front. But it turned out ln e is what? Is 1. So if I simplify, you have 1/3 outside, multiply each term by 1/3. So you have 3 cancel 1/3, you get 1. 4 divided by 3, you get 4 over 3. And here negative 4 divided by 3, you get negative 4 over 3. And then that is the maximum we can simplify. And then I have to take the derivative of both sides. Then I took the derivative of both sides. And then what you have in the middle, or you have in the middle plus, you have in the middle minus, means you are going to take the derivative term by term. Here is the derivative of the first term, the derivative of second term, minus the derivative of the third term. What is log f? 1 over f y prime. Here, what is your fy? So 1 over y prime, ln x 1 over x prime. 4/3, it's a constant. I took it out. What do you have left? X prime. 4/3, I took it out. What do you have left? ln or log x plus 3 prime. So what is the derivative? It will be 1 over f prime. And then multiply, I solve for y prime by multiply both sides by y, as I did. And then you have to substitute on y from what is given the original y. Then I got y prime, and everything on the right hand side now is a function in x. Is a function in x. Okay, guys. All right. I will stop here. That is very much our log of differentiations. So I want you distinguish between log differentiation and exponential functions and Bauer what's called polynomial functions. Polynomial function, as I start in the class, it's like shortcut formula here. That is the one that's called polynomial. Exponential, that is the one. But here, if you have x to the power something like this, or you have something very complicated, when you use law of log, make our life very easy. And then I'm going to take the derivative after I simplify. All right. Thank you. I will stop here.